ice skating looks almost magical. A skater glides smoothly across solid ice with very little effort, reaching impressive speeds and making sharp turns with precision. But this raises a simple question. Why is ice so slippery? Many people have heard that ice skating works because the skate blade melts the ice beneath it. That explanation sounds reasonable, but it turns out to be only part of the story. In this video, we'll look at the real physics that makes ice skating possible. The most common explanation goes like this. Skate blades are very thin, which concentrates a person's weight over a small area. That creates high pressure on the ice. High pressure lowers the melting point of ice slightly, causing a thin layer of water to form. The skate then glides on this water layer. While this idea isn't completely wrong, pressure alone cannot fully explain why skating works so well. There are several problems with the pressure-only explanation. First, ice is already slippery even when you're just standing on it, with no motion at all. Second, the pressure from a skate blade is often not enough to melt ice at typical skating temperatures. And third, people can skate outdoors at extremely low temperatures where pressure melting should not occur at all. Clearly, something else must be happening at the surface of the ice. When a skate blade moves across the ice, friction comes into play. Even though friction is small, it still produces heat. At the microscopic level, even a tiny amount of heat can have a significant effect on the ice surface. This frictional heating slightly warms the ice directly beneath the blade as it moves, changing how the surface behaves and preparing the conditions for smooth gliding. The key to ice skating is a microscopic layer of liquid water that forms between the blade and the ice. This layer is extremely thin, thousands of times thinner than a drop of water, but it plays a crucial role. The combination of frictional heating and pressure helps maintain this water film as the skate moves. The water acts as a lubricant, greatly reducing friction and allowing the blade to glide smoothly across the ice. Ice has a special property that makes all of this possible. Even when ice is well below freezing, its surface molecules are slightly disordered, forming what scientists call a quasi-liquid layer. This means ice is naturally slippery even without motion. Skating takes advantage of this unusual surface behavior, enhancing it with motion, pressure, and frictional heating. So ice skating is not simply a matter of pressure melting the ice. Instead, it's the result of frictional heating, a microscopic water layer, and the unique surface properties of ice itself. Together, these effects allow skaters to glide, turn, and stop with remarkable control. The next time you watch Olympic skaters racing across the ice, you'll know that a beautiful combination of physics is at work beneath their blades. Thank you for watching.